Hello, everyone. My name is Michael Gardner, and today, with the help of my colleague, Krishna Turlapathi, we're going to be going over design considerations for migrating your HPCC Systems data lake over to the cloud. This talk is intended for wider open source community. It's advised that you check with your organization for any specific security protocols and best practices that you're going to be making. Please feel free to go ahead and follow along and in the chat feature and engage us with questions as we go about the presentation. The first thing that we're going to be discussing is the differences in layout and setup between what we would consider a traditional HPCC systems platform that runs on bare metal and the ones that you'll be using as you move towards the cloud. So let's go over some key points about a traditional HPCC systems platform cluster as a bit of a primer. First thing to take note of here is that there's a need for homogeneous configuration files to be deployed across an entire cluster. This means that every single one of your physical nodes in your cluster needs to be accurately describing the entire cluster. This can often cause issues when standing up large clusters. Synchronizing an entire cluster's environment.xml files can sometimes be error prone. And debugging a cluster's health when these files get out of sync can cause major headaches. Second, in the traditional HPC systems platform cluster, there's no standardized way of creating a cert and key vault. Common practices for this is for operations to ensure that keys and certificates are deployed to nodes using third-party tools and stored in the appropriate locations in the node's local file system. This has many of the same headaches for operations as deploying the environment.xml files. These configuration considerations can cause an issue with scaling up a cluster quickly. Setup and testing of traditional HPC systems platform clusters can take a considerable amount of time. And this is on top of doing all your other due diligence testing for whenever you set up a new cluster. This means that oftentimes when we set up a traditional cluster, we always leave it on. The cost of deploying a large cluster for a nightly batch job or for queries that you know will be arriving during set periods of time throughout the workday might be a higher cost than just leaving the cluster on all day long. And this is a potential waste of resources. And so that's one of the reasons why we're moving towards the cloud. So let's look at what the HPC systems cluster in the cloud actually is going to end up providing you and the design considerations that you need to think about. The cluster has been redesigned to utilize tools like Kubernetes and Helm to allow you to configure and deploy your cluster of HPC system services as containers. These new containers are described using YAML configuration files. This language tends to be easier to work with than our old traditional environment.xml files. They tend to be less dense and they still accurately describe the final state of your cluster. Because we're using Helm charts and YAML configuration files, we can now think of our configuration of the platform as code instead of just environment configuration files that we're spraying out and then worrying about at startup and runtime. Modification to these YAML files and updating the Helm chart can push changes quickly across the HPC systems platform in the cloud. It's very easy to reconfigure a cluster and to have Kubernetes update it using Helm. This also means that templating clusters and scaling clusters using Kubernetes based on the current state of the cluster is much easier to achieve. Another thing to consider when thinking about HPC Systems cloud layout is storage. Now we have the centralized planes where you can mount onto your cluster. These change slightly depending on your cloud provider, but they'll integrate into your platform seamlessly using the YAML files I mentioned earlier. The cloud implementation of the platform will also give you security up front. Several security features are turned on by default. We have same defaults that we believe are going to be general best practices, but of course for your organization, you should do your due diligence and make changes as necessary. And the ease of configuring these security features, it's been much easier to actually implement them for your cluster. Because of this, the cloud also allows for on-demand processing because now we're configuring by code and we're deploying through Helm and Kubernetes. The ease of setup and deployment has tremendously increased. As end users, you can launch a cluster when needed or set up scalability options for your cluster to allow HPCC system services to scale as more resources are needed. So now we're going to have just a quick overview of security as we go into the cloud. And these are some very basic considerations that you should think about. First off, encryption and transit. All right, so despite the fact that cloud providers often supply private subnets for your resources to run on, we should still be wary about intrusion and packet sniffing attacks. This means encryption and transit should be on by default. Setting up HTTPS encryption in the cloud is much easier than with bare metal and simply requiring the appropriate certificates in a centralized vault. Then we also have encryption at rest. And depending on your cloud provider, this is going to change somewhat how it's done under the hood. But generally they use the centralized keys in your vault and encryption of blob storage or S3 storage can be done relatively seamlessly. Certificate and key management is also handled differently in the cloud than it is on bare metal. There's been quite a bit of work done by the HPC Systems platform team to allow for you to use tools such as the HashiCorp Vault to deploy certificates and keys to centralized stores in your cloud provider, and then serve them out to the individual service containers using simple YAML settings. A really good in-depth walkthrough on this is the blog by Nikita Jha on our HPC Systems website, and I'll link to that in the chat. The last security consideration that we'll go over as you're moving your platform to the cloud is access control. And generally in the past, there's been different ways that you do this, but we're trying to allow for you to use OAuth 2.0 and Microsoft Active Directory seamlessly through the cloud. And of course, depending on which cloud provider you go with, depends on which one that you'll end up using. But you should definitely think about using those as you're moving into the cloud and not just require access to the subnet as a way to access your resources. Now, data storage in the cloud has changed somewhat too in comparison to bare metal. The biggest change is now you can quickly have something called ephemeral storage. Now, this is storage that does not persist. It's temporary. It's very good for testing purposes, for starting up clusters and getting a proof of concept done quickly. But all the data that you put on it, of course, is going to be torn down when you bring down that cluster. Now, opposite of this is something that we have called persistent storage. Persistent storage is, of course, data that persists after you bring down your cluster. This is allocated in data planes that then can be mounted across multiple clusters. And the data mounting across clusters is much easier in the cloud than it was in traditional bare metal installations of the platform. It's simply a modification of your YAML files to say where the data is, the appropriate keys for decrypting that data, and then a mount point. So once you set it up in the YAML files and set it as code, you can easily use that across multiple different clusters whenever you spin them up. And with those considerations in mind, I'll pass you along to my colleague, Krishna.
Hi, I'm Krishna Turlapathi, and today I'm going to go over and take a look at designing your HPCC cluster to meet your requirements using values.yaml file. And I'm mainly going to focus on the ROXIE section of the YAML file. In addition to this, we're going to take a look at how to migrate your ECL queries to cloud and how to migrate your data to cloud using package files. The ROXIE section of the YAML file, which is part of the helm chart, looks like this. In order to add your helm repo, you can just use the helm repo add command, and you can get the helm chart from the GitHub. This will add your HPCC to your repositories. You can create a multi-node cluster or a multi-single node cluster based on your need. To achieve this, we will change the value of local agent. To create a multi-node cluster, set local agent to false and install or upgrade your HPCC cluster. To install your cluster, run helm install command. After your cluster is up and running, you can run kubectl get pods and see that it has created multiple ROXIE agents. If you want to create a multi-single node cluster, set the value of local agent to true and install your HPCC cluster. To install your HPCC cluster, again, run helm install command. After your cluster is up and running, you can run kubectl get pods and see multiple ROXIEs running. You can modify or upgrade your HPCC cluster by running helm upgrade command and passing in the modified YAML file. Now that our cluster is up and running, let's get the IP addresses associated with the services that are running. You can run kubectl get service to get the list of services and the IP addresses associated with those services. You will need these IP addresses when you want to copy your queries, you compile your queries, or deploy your package files. The two most commonly used IP addresses or services are ECL watch and ECL queries. And in addition to that, you will need the DALI IP address in order for your package files. Now that our cluster is up and running and you have the IP addresses for the services, let's take a look at how to migrate your queries to cloud environment. Before you start migrating your queries, make sure all the pods are running and in ready state. To get your queries on cloud, you have two options. You can either copy your existing queries from bare metal to cloud, and this is assuming that you're running same or compatible version of the HPCC platform on both the environments. If your platforms are not compatible, you might have to recompile the queries once you copy the queries over to your cloud environment. Or you compile your queries directly on cloud from your Git repository or your local ECL files. In order to copy your existing query to cloud, you can either copy individual queries using ECL queries copy command, or you can copy your entire query set using ECL queries copy set command. To compile your queries on the cloud from your Git repository or local ECL file, use ECL publish command from your command line, or you can use your IDE to compile the queries and then publish them. Now that you have migrated the queries, let's take a look at how to migrate the data associated with those queries. We're going to use package files to accomplish this. Even here, you have two options. You can either copy your existing package file or create a new one and add the package file. If you want to copy an existing package file from your bare metal to cloud, you can use ECL package map copy command. If you want to add a new package map, you can use ECL package map add command. Once you have deployed your package files, you can see the logs on the pods and notice the data copy starting. In order to get to the logs, you can just run kube control logs command to see the logs on the individual pods. If you're updating a package file where you're just modifying some keys and publishing the package file, and assuming that you're using persistent storage, once you add your package file with any new additions or modifications to the existing package file, you can run the kube control log command and notice the value lookup in the logs. This is where it is verifying the keys in your package file actually exist. Once you have done this, now you have a fully functioning cluster created as per your requirements with your queries and data available. Now you can use ECL Watch to look at those files and the queries, and you can use WSECL to actually run those queries. These are the list of command line options available as part of HPCC. We have used a couple of them in this presentation. Thank you, and let us know if you have any questions.